Welcome to Datadog Illuminated. At Datadog, we have a monolith. This monolith has thousands of HTTP endpoints that serve Datadog's web app. Like any company looking to modernize, we want to refactor these endpoints into microservices. Normally, a migration like this could take years of tedious work, but Nick Isaac and Datadog's AI DevEx team are using Gen AI to build something new. A workflow that uses LLMs to do these migrations. The goal here is for the Datadog web app monolith get completely dismantled. I wanted to know how this monolith into microservices process worked. So I invited Nick to walk through the whole workflow with me step by step. What goes in? How is the LLM's work verified? What guardrails are in place? What happens when something breaks? Nick tells all, including which parts are working well versus where they have room to improve. So let's do this. All right, I'm here with Nick. Nick, will you introduce yourself, please?
Yes, hi everybody, I'm Nick. I work on the AI DevEx team at Datadog. We have two main tentpoles in our charter. One is to make sure that Datadog engineers have everything that they need access to as it relates to like generative AI tools to help them in their jobs. So making sure they have access to all of the latest, greatest tools, Claude Code, Cursor, et cetera, et cetera. And then the other thing that we do is we try to push the boundaries of what's currently being done and what is currently possible to do with LLMs as it relates to software engineering at Datadog.
So your team kind of helps developers take full advantage of generative AI, whatever that means. We're figuring it out as we go. Is that what
Exactly.
I hear? Yeah.
Yes.
Awesome. Speaking of that problem space, you and your team are working on a tool, I understand. Will you first describe to me what problem your tool is solving?
So at Datadog, we have got a monolith, which has been at the company for quite a while, and it serves a whole host of routes, which are generally used to power like the web app. And over time, the code base has grown quite large, and Datadog has self-evolved. And we now generally no longer prefer adding routes into this large monolith. We generally prefer writing routes into a service framework that we have developed internally. But this monolith still deals with a great deal of traffic. And for a whole host of reasons, ideally, we could take those routes and we could move them into their own appropriately sized services.
And what is the benefit of extracting these microservices out from the monolith?
I would say it's two primary motivations. One is operational stability. So, a large shared monolith comes with shared operational concerns, shared outages. It has a larger, blast radius for changes, whereas smaller, more contained services allow teams to move independently, move quicker, and don't have to worry about breaking other teams' routes if they make a change.
Yeah, when you have something ready, you can just release it. You don't need to worry about what everyone else is up to. So we have this Datadog web app monolith. It has thousands of HTTP routes. It needs to be migrated to a services framework that already exists. And so what is like the actual, like the end goal of the tool that you're building?
So the end goal is that we can completely decommission this monolith. It's not to say that every single route will be rewritten into our new service framework. Some might be decommissioned entirely. But the majority of them will be rewritten just that we can turn off the monolith.
Rewriting and or getting rid of. I like that you're specifying, like we're not just rewriting. And then given that you're on this like AI DevEx team, I am making an assumption that this tool you're building to help decommission the Datadog monolith, to break it up into microservices, is powered by LLMs. Is that a safe assumption?
Yes, that is a safe assumption.
Cool. We're going to go through today like an LLM workflow that you use. I understand this is something in progress, right? Something you're working toward, or do you feel like this is in its final state, this tool you're building?
I would say we're definitely in the building phase. Past about 2 months, getting this in a place where we feel like we've built conviction around the approach, and we'll continue to invest in it until it's able to do everything we ask of it.
And then we're going to talk about the state it's in today. But what have you gone through to get it into today's state? Like how long have you been working on it? Like were there other stops and starts?
So we've been working on this for about 2 months, and we've gone through 1 or 2 iterations of how to actually approach this problem. And so I would say we're currently on the final iteration of what the ultimate tool will look like. And we're in the process of refining how specifically it works.
I'm going to start a list here of tools, right? And tools are like technologies involved in this.
Mhm.
For example, the code that the monolith is made up of is mostly Python, correct?
Yes.
But what tools are at play here at the beginning and we'll add more as we go?
So in the workflow, we use Claude Code to actually do the
Okay.
code transformation. We use GPT-5 to do a code review, which we'll talk about later as we get into the details. Yeah, we orchestrate all of the steps of the workflow with LangGraph.
Okay, and if you don't know what those are, we'll talk about it. We'll get there. So where do we start? What triggers this workflow, and what does the workflow do as part of step one?
In the ultimate version of the tool, there'll be like a web UI, and we'll click a button and that will dispatch a workflow. But currently, we're running this in what are effectively EC2 nodes, in large batches. So the input into the first step of the workflow is the route that we want to migrate, and we tell it where in the Git repository the current implementation lives, and then we also give it a destination. So we've already pre-created the set of services that we want the routes to end up in. And so we say, hey, workflow, you're going to take this route, which currently lives over here, and you're going to rewrite it into the service, which lives over there. We refer to this as gather and plan. And so gather and plan. Yeah. So we're giving the Claude Code is what we use to actually do the transformations. And so we hand Claude everything it needs to know about the current monolith. So we have documentation that we handed about the current monolith implementation. We hand it documentation about the new service framework. This is an internal to Datadog service framework.
Okay.
And we also give it a series of instructions how we would like it to perform its task. And then we have it go and read all the code and create a plan of execution for the code transformation.
So we have a gather and plan step. It has the current monolith docs. It has the services framework docs that we kind of mentioned up top, and that's where we want it to go. But as part of the service framework, it has a destination repo, right? And then we're also giving it instructions, like a prompt.
Yep.
When we say instructions, we mean a prompt. So destination repo. From this, our output that we want is just a big old plan to pull out the endpoint from the monolith and put it into the microservice, right?
Yep, exactly. So the plan includes, everything it needs to know about the route. In addition, all the tests that it should add. So tests that currently exist, as well as potentially new tests that we would like it to add to verify behavior.
So the output is plan and tests.
Well, it's just a plan, but the plan includes the
plan
everything. The plan, yes. It's a plan to write
the test plan.
Plan to write the test. Yes, exactly.
The code plan, the test plan. We're just going to write plan. It's a big old plan. So we did for step one, gather and plan. And now we're moving on to step two. What is step two?
So step two is it's kind of go ahead and do it. Take the plan and execute it. Do the thing, yeah. And so we also use Claude Code for this step as well. So we pointed at the directory containing the new service, and it will go ahead and implement the plan. In addition to the plan that it generates, we make sure to give it specific instructions around here's how to run tests in this repository, how to take steps to validate your work. Basically, prompts in addition to the plan outputted by step one.
So execute the plan. And so there's like a prompts around execution itself, prompts around writing tests.
Yep, exactly. Best practices to follow, how to organize the code, both how to organize the files, what kind of directory structure to use, things like that.
Code, prompts for tests, organization. And then it also just has free reign to navigate the monolith and the services framework.
We give it access to directories that contain all of the relevant code that it needs.
I'm interested. We could talk later about guardrails, about how, because it's scary. Okay, so it has access to all the things. That's the input, and then the output is.
The output to this step is the changes. So at this state, we'll have a Git repository that has a bunch of uncommitted changes in it, and we're not quite done. But we do have code.
Code. Is it okay to write probably not very good code yet?
I think that's a fair assessment. Yeah. Not
Cool.
quite good, but okay.
Okay. Cool. So we gathered and planned, and from step 1 and 2, we took that plan and we sent it over to step 2, which executes on the plan. And so now, what happens to that just okay code it's written?
So after step 2, we go through this 3-step verification process. At a high level, the individual steps are 1, run the type checker, fix any issues that crop up. 2, run the tests, fixing any issues that crop up. And 3, go ahead and start the service, fixing any issues that crop up. And the key insight here is that we gave this 3-step process the ability to loop through itself until completion. So for example, if we run tests and they fail, what will happen is we'll take a pass at fixing the tests, and then we will loop back to type checking. And the idea was that we were mirroring the typical sort of software development lifecycle flow, which is first I might get the type checker passing, then I'll get test passing, and then finally the highest level of verification, I'll start my service.
Who's supplying the test? When I'm personally trying to do TDD with Claude Code, sometimes it isn't great.
Claude is writing the tests. So
Awesome.
It's taking what is currently in the mono repo. If tests exist, we'll port those over. And then we've also given it instructions for the kinds of tests that it should write and how to write those tests. So we've taken a great deal of care to make sure that it's producing high quality tests.
Another problem I personally have with Claude Code is sometimes instead of fixing the code that the test is testing, it changes the test to make the code pass.
Yeah. After we get through this whole verification loop, we then move on to another step in the process, which is a code review.
Okay. We won't jump there because I want to talk a little more about the looping. So you said run type checker and fix issues. And so once that's done, it runs the test and fix issues. But if the tests don't pass, you said it cycles through these. Like is it going to, this is going to go until it passes and this is going to go until it passes, or does it go back and write code again?
So it'll go back to step 3. So step 4 will go back to step 3.
Okay.
It requires revisions, and step 5 will go back to step 3 until all 3 pass sequentially.
So if there's a fail, it'll fix the issues, but then it'll go back here.
Exactly.
And similarly, if there's a fail, it'll fix issues, but then it needs to start the verification process from the beginning. That makes sense. Now you said these are all Claude Code steps. You also said this is orchestrated by LangGraph.
So LangGraph is a tool to allow the, we'll say, deterministic, composition of small individual steps. And so we have one step, which is the gather and plan phase. We have another step, which is the do the thing, execute the plan, and so on and so forth. We had a previous version of a workflow, which was, a little bit more single prompt with examples. And we found that we didn't get great results out of that. It didn't always produce complete work. It didn't always produce complete tests or passing tests. And what LangGraph has allowed us to do is decompose this problem into a smaller series of more manageable steps and improve those individually.
That makes a lot of sense to me. And my personal playing with it all, if the AI knows the final goal, it'll be lazy and skip ahead to the final goal and make assumptions. But if it only knows this much, then it'll do the little bit that it's aware of. So I love that that's been formalized here. And it's my understanding that that LangGraph itself is deterministic. So this is always going to go to step 2. These looping parts between steps is a deterministic thing. So now we did the thing, we have some code, probably not good, but now that we've been through verification, it's better code. And then what's next?
So up next, we take the diff that we've produced and we provide that to GPT-5 for a code review. So we give a GPT-5 agent the code that we've changed, and then we also give it access to explore the directory structure as needed in order to do a thorough code review. So it's going to need to read the current code in the monolith. It's going to need to read the current code or the newly generated code in the service, or as well as potentially any libraries. So our service framework, the monolith framework, things like that. So we give it free reign to read what it needs.
Okay. I'm going to have you repeat a lot of that to write it down, but I have questions first. The code reviews by GPT-5. Do you think it's important to get another model involved to help critique one model?
Anecdotally, we have found that the types of feedback that we get from the model is different and beneficial than what we saw from the Claude Code based reviews. That being said, it's definitely an active area of exploration. What's the best combination for each of these steps?
I think there's so much experimentation, and even when you do know something, the models themselves change so quickly that whatever you once knew is kind of out the window. So I do get and appreciate the doing it with with another model. And so we're going to do the code review by GPT-5. And so I like talking about inputs and outputs. So the input is the code diff, but it's more than that. It's the code diff. Is it plus basically the same inputs as this, where it has like all these prompts plus access to the monolith and the services framework?
Yes, we give it prompts. Similarly, we give prompts about the monolith it's operating in, the new service framework, as well as the goal of the migration. And in addition, we give it the diff, and then we also allow it access to read files as it sees fit.
And then it has access to the monolith and the services framework, both.
Yes.
And then what's the output?
It's one of two things. Either it passes, meaning behaviorally, it believes that the code is identical, or a list of discrepancies that it's found. So if it passes, at this point, we're effectively done with the workflow. And if it found some discrepancies, we'll perform a similar workflow as we did in the first step.
Okay, 1 passes or 2 discrepancy. Cool. So here's our step 6. We have code review by GPT-5. It gets code diff and has access to prompts and all sorts of things and instructions, and then access to the repos, the monolith and services framework. And then it either passes or there are discrepancies. What if there are discrepancies, then what happens?
If there's discrepancies, we take that list of discrepancies and we pass it to another step, which is similar to step 2, which is it's got context for what we were trying to do, and it's been given the list of discrepancies, and we have Claude address them.
So we're doing the same verification process, the same 3 steps?
We'll take one pass that's sort of, hey, address the feedback, and then we will go into the verification workflow.
So a step 7, address discrepancies, and then that outputs code. And then we go through our verification steps. My poor face, I want to be able to look at you. Okay, so we're going to do step 7 up here. Do we need to say more about that?
It uses broadly similar set of prompts to step 2. So, we've given it context, grounding it in what it's trying to do, grounding it in the 2 code bases that it's operating in, and giving it a list of discrepancies. That's more or less it. And we let Claude address them. We make sure to give it some prompts, indicating that, hey, make sure you reflect on each of these points first, write tests that verify to the greatest extent possible each of these discrepancies. But broadly speaking, it's very similar to the original transformation step.
So we say output code here, but this code, technically it's outputting tests here too then, right?
Both are. So they're all operating on the same copy of the repository. And so step 2 comes through, it makes some changes to the code, then those get verified. Then we take the current status of the repository and we give that to GPT-5. And then step 7 again is operating on that exact same copy. And so it's working on step 7 picks up from where step 5 left off in terms of the code state.
Okay. So address discrepancies, Claude Code's doing this. We're back to Claude Code.
Yep.
And then we're going to go through the same verification process.
Yes.
Will you tell me, please, what Temporal is?
Temporal is a durable job scheduling framework. So it allows us to run, long-running jobs and make sure that they get restarted in case of failure. So, for example, if our node runs out of memory or some other resource and it hits a timeout, the jobs will get restarted and run till completion.
Is it instead of or in addition to LangGraph?
The way that we have things orchestrated is the LangGraph workflow represents what I call the inner loop. So for a single route, it will do the transformation. And then we use Temporal to orchestrate the run across all of the endpoints. And so each endpoint becomes its own temporal job, and the temporal job invokes our workflow.
So when you're talking about doing this at a large scale across, we have thousands of endpoints, that's when Temporal comes in. Our discrepancies go here to 7, and then we're our same verification process. I guess that's a question, not a statement. I know it's the same 3 steps, but is it also like if run tests and fix issues fail, we're going to start back at type checker, presumably? Yes. These go from here to here to here, and this is the new code being passed down. And then if it fails, goes back here. And if this one fails, it's going to go back to type checker and start again until it all passes. Will that just run infinitely until they're all happy?
Not infinitely, but we do give it a large number of attempts to get it right.
All right, so now we have code probably not good, better code, even better code. Woo, it's getting to be maybe good code. Now what happens?
So at this point, we'll open up a PR with the current state of the repo.
When you say we, who's we?
So that would be the temporal job.
Okay.
So the temporal job runs the workflow. That generated diff gets turned into a pull request for human review. And in addition to that, we'll also deploy the service into a staging environment.
For simplicity's sake, is it okay to say the workflow opens a PR?
Yes.
Okay. We open a PR, step 11, step 12, deploy to staging?
Yes.
Okay. And then what?
And this is the point currently where we would hand off for human review. Where we would like to get to is we'd also like the ability to have, whether it's Claude Code or some other code agent, iterate against the results of the deployment to staging. But currently, this is the last step in the process.
So later, this will get its own evaluation, like LLM-powered evaluation.
Yep, deploy to staging and hand Claude Code or some agents the ability to look at the results of that staging traffic.
So very quickly, I'm going to jump back to 6 because we have, maybe it might pass. So if it passes, does it go skip to 11?
Yes.
Okay, discrepancy passing goes to 11. Cool. And then we have human review. It's good enough that the human is either going to approve it or manually get it to the right spot, or is there a chance that the human's going to be like, send it back somewhere else in the workflow?
So currently, this is the last step in the workflow. Our goal currently is to get to a spot where for some percentage of routes, the human has to do nothing. They look at the code, they think it is well written and well tested, and it's passed staging verification, and so it's purged and deployed. Currently, where we are in the process, we're still actively developing. We're not quite to the level of quality where we want to turn this on for every single route, but we're certainly working towards that fully automated future.
Version deployed. Huzzah! Woohoo! Did I skip ahead? After human review, I made an assumption that that's next.
No, that is next.
Okay,
Version deployed.
So you're saying, okay, we're not ready yet for this to go out across everything. I want you to be more specific about that. Like, what's some room for improvement?
We're currently at a place where the code that's generated reads right. One thing to note is we're not always experts in the code itself, how it should work. So the best that we can do is sort of compare before and after. The tests that are written are passing at well above a 90% pass rate for the unit tests that are written. We're not always passing integration level testing, so we have various levels of testing at Datadog. So currently we're focusing our efforts on specific types of failures that we're seeing in integration testing. This is a relatively large migration, and there's been, I would say, oftentimes maybe years of active development between when the endpoint that we are trying to migrate was written and the new sort of the new standard of code. And so we're working on ensuring that for every data store access, every service call, that we're using the latest and greatest versions of, so let's say it's a Postgres client, making sure it's using the new Postgres client, making sure it's using the latest and greatest gRPC client, things of that nature.
It's not always passing integration testing. How do you measure success? Like semantic similarity is what you said, maybe?
Semantic similarity, we take that to mean when we put it through staging traffic, it's producing identical responses. So it's producing identical, in the case of HTTP routes, which these are, it's producing identical response codes and similar response bodies. And we do have automated testing at Datadog, which verifies via shadow traffic whether or not two routes are identical.
So we do that. You were kind of saying, like, as AI of DevEx engineers, like messing with someone else's microservice, we don't actually know that much about the microservice we're messing with. And so I was trying to capture that in a room for improvement bullet point. But maybe that's just a statement of fact and not something that needs to be captured here.
Yeah, that is an invariant that we have to work with, is we can't be experts in, thousands of routes. We can't be experts in all of them. And so we need to produce this workflow in a way that it can become an expert in the particular route that it's operating on.
So how to measure success and consistency. Okay. And then how to stay current with the latest tooling. Not really tooling for the workflow, but you were talking about like the most current Postgres or whatever.
Oh, yeah. So we've been working to add to this workflow what effectively amounts to prompt instructions that guide it towards, hey, if I see this outdated access pattern, I'm not going to copy it one for one. I'm going to copy it in a slightly different format. There are a small number of outdated access patterns, which we might not want to carry over.
So modernize while migrating. And then what do you think it is you're doing well?
Sort of the positioning when we started this work was this is exploratory. We thought that, in playing with Claude Code and in playing with Cursor and all these LLM-enabled tools, that it was certainly theoretically possible to do this successfully at scale, but we hadn't actually seen it done ourselves. And so there was a little bit of exploratory work to validate that this would in fact be fruitful. We absolutely have conviction that this is the right path forward for doing these large migrations, not just for this instance, but also across infrastructure at Datadog. And I think we're also learning what are the missing building blocks of authoring these large scale transformations. It's one thing to sit down at my editor or with Claude and make a singular change, but if I want to affect a similar but different change 1,000 times, what is the tool set needed to do that well? And in particular, how do I run that at scale, and how do I ensure that there is a feedback loop? So the first migration improves the second, improves the third, and so on and so forth. And I would say we're learning what the shape of those tools is, but we don't always have solutions for all of them.
In terms of numbers, there are thousands of routes that need migration. How many have been migrated?
Currently in production, I think there's a very small number. It's single digits. In terms of how many we have successfully run for, we've successfully been able to generate, in the tens. So somewhere, about 100, not 10, somewhere in between there.
Do you get teams to volunteer to go through the process? How do you decide which ones to migrate first?
This is very what we call producer-led migration. So instead of opening 1,000 Jira tickets, having every team, take a little bit of the work, we're centralizing the work. And so we ourselves are running this workflow, and we're starting with teams that we've gotten permission from to do this. And this was important. We felt that, now that we have these tools, it was not feasible to do this style of migration beforehand. But now we actually can have one team sort of run end migrations. And now the bottleneck is on the code review. And we'll be working to make that more efficient as well.
So what you're waiting on to take this across the organization is the human review or this code review?
The human review. Step
human review. Okay. Yeah.
Once we do start to run large batches, we'll find ourselves waiting for pull request reviews. And that's when we'll have to solve that next problem of, okay, how can we make that better, faster, more efficient?
And is that what you're waiting on to roll this out?
Currently, we're still working on increasing the quality of the generated code. We have a large percentage of unit test passing, and we're working on getting through the integration test suites that currently run. We're already happy with the quality of the code. The partner teams that we're working with are also happy with the quality of the code. That gives us confidence that the code sort of reads and does what is expected of it. And we are working through getting through CI. Our posture is if I give you a PR and it's got failing tests, that's just noise. That's not really helpful. And so we want to get to a spot where we're passing CI entirely. And when you get the PR at the end of the day, it is green and you can feel as confident as possible in the generated code.
I'm going to do a quick wrap up. We have a Datadog web app monolith. It has thousands of HTTP routes, and it needs to be migrated to a services framework that already exists. And so the goal of this whole project is eventually to decommission the Datadog monolith. We want the whole thing gone. We're going to rewrite and or get rid of all the endpoints here into microservices. We have an LLM workflow that's going to help us with that. The first step of the LLM workflow is the gather and plan step. So for that one, we're taking documentation about the current monolith, documentation about the service framework. We're taking the prompts, the instructions. There's a destination repo that already exists as part of the services framework. And we're using Claude Code here, and we're outputting a plan. And so that's the end of step one. So now step two receives that plan, and it also receives prompts to write the code, prompts for writing tests, prompts for directory organization, that sort of thing, lots of prompts. And then it also has access to the monolith itself and to the services framework. And then it outputs the thing. It does the thing. It outputs the code, and tests for that code. But the code is probably not good yet. So we take that code and send it through a verification process that is a bit of a loop. It's first going to do type checking and fix any type issues around that. And then it'll go to the next step, which is to run tests and fix anything around that. If it does fail and need to fix, it's going to go back up to the type checker. And then type checker, then run tests. And then if that works, then it's going to start the server. If there are any issues, it's going to fix those, but then go back to the type checker. And then all the way through until all of this passes first try. And then we have a code diff. And that is the output of this part of it. And that code diff goes into a code review step. Now, this time we have a different model. GPT-5 is doing our review. And so it's going to receive a similar input to step 2, where it gets that code diff, but it also gets prompts, the goal of the migration, access to the Monolith and services framework. And then it's going to do one of two things. It's either going to pass or it's going to have discrepancies. So if it has discrepancies, then it's going to go to step 7, the next step, which is to address those discrepancies. And we're back to Claude Code now. It's going to get those discrepancies, and then it's going to get context and prompts, and similar to what we've been talking about before. And then it'll output code that fixes the discrepancies and then test for that code. And then we're going to go through the same verification process as last time. Type checker, run tests, fix issues, go back up to type checking as needed until all of that passes, and then it opens a PR. If the code review step passes, it's going to skip all that and go straight to opening the PR. And then once we open the PR, it gets deployed to staging. Temporal does that. And then we go to a human review. And when the human says 2 thumbs up, then it's merged and deployed. Huzzah, woohoo.
Exactly.
So this is huzzah, woohoo. So this is exploratory. We're validating a concept here that eventually, once it's refined, could be rolled out org-wide and accomplish this lofty goal. You said the unit tests are pretty good, but integration tests are not always passing. You said, how do we measure success and ensure consistency when your team that's making this tool can't understand all of the code that's going through it? How do you make a system that understands the code well enough that this could be done consistently? We also talked about when we migrate stuff from the monolith to now, we don't want to migrate old, like bad patterns and old tech. Like we want to modernize while we migrate. So that will be a lofty goal to make this process even better. But in terms of success, this workflow itself is a success. It has great potential. It's always being improved, but you have been able to run it successfully and do this successfully with several microservices.
I would say, as a whole, we're feeling very excited about, continue to invest here and then scaling it up. I've done migrations similar to this before we had these kind of tools, and it was a very different world. So I am excited to be pushing software development in this direction.
Me too. We're living in the future. Well, thank you so much, Nick, for being a guest on Datadog Illuminated. I appreciate you so much for sharing your time and expertise.
Thank you, Whitney. Appreciate it.
Bye.